Okay, so today we're covering section 4.6, negative and zero exponents. This is very much an extension of section 4.5, meaning that we're still going to be using our two properties that we learned, product of powers property, quotient of powers property, when we're simplifying these exponents for numbers that have the same base. Okay. Before we do that, there are two almost rules. Okay. The variables might be a little confusing, so I'm just going to give you some examples. But these two rules apply to all numbers, okay? If you take any number, let's say the number 8, and you raise it to the power of 0, the answer is 1. Same thing goes for variables. So you take the variable g, and you raise to the power of 0. That actually is 1. Any variable raised to the power of 0, even if you don't know what the variable equals. All right? Raise something to the power of 0 and it's 1. Raise a very large number to the power of 0 and it's still 1. You get the picture? Raise any number to the power of 0 and it's going to be 1. All right, now, in the second rule, it says take any number with a negative exponent. Okay? And we treat it like a fraction. So we know that a whole number can be placed over what? And made into a fraction. We can put any whole number over 1. Okay? So this can be placed over 1. This is understood, right? We know that any whole number can be over 1. So if I have a negative exponent, what happens is I do the reciprocal of that term. When I move it to the other side of the fraction, it changes the sign of the exponent. So now instead of 3 to the negative second power, I'm going to put it in the other side of the fraction in the denominator, and it now makes the exponent positive. That's what my rule says. Okay? So I want you to convert 2 to the negative third power. How would you write this using a positive exponent? How could you change the sign of your exponent? What would it be?
1 over 2 to the third.
1 over 2 to the third. You just move it into the other side of the fraction. What if it's 1 over 3 to the negative third power? What if the negative exponent's in the denominator? Can my rule still work? Okay, so my rule does still work. If I want to write this number using only a positive exponent, I move it to the opposite side of the fraction. So now I move it from the denominator to the numerator, and what's it going to be? 3 to the third power. I don't even need to write it over 1 because that's understood. You see? So if the directions say, write your answer using only positive exponents, it means take that term and put it in the other side of the fraction. Okay? So, and that reverses the sign of your exponent. All right, so those are your two rules. So here's what it looks like in example 1. This is the first section on your homework tonight too. Writing powers with only positive exponents. There's not necessarily anything to evaluate. You're just looking at this term and you're saying, okay, there's a negative exponent there. So how do I get rid of it? Well, what I do is I write that number in the opposite side of the fraction. Well, if it's a whole number, what side of the fraction is it in? Numerator or denominator? If it's a whole number. It's on top, right? Right? Okay. So 3 to the negative fifth, if I wanted to write it using only a positive exponent, I write it in the opposite side of the fraction, 1 over 3 to the fifth power. Right, now in the second example, okay, this is kind of different. We just talked about what happens to a term when I raise it to the power of 0. It becomes 1. So guys, I want you to rewrite it. 1n to the negative fourth. Do you see why it's a 1?
Yeah.
Okay, you say, well, where'd the m go? M to the power of 0, guys, is 1. Any variable to the power of 0 is 1. So which term needs to move to the denominator? The only one that has the negative exponent, which is which one? N to the negative fourth. So now I leave my 1 on top, and I move n to the fourth to the bottom, and to the negative fourth, so I can write it as a positive exponent. All right, so If I have a negative exponent, I can write it in the opposite side of the fraction and it becomes positive. All right, look at the third one now. Now look at the third one. In the third one, I only have one part of this number that has a negative exponent. Do you agree?
Yes.
Does 16 have a negative exponent?
No.
Nope. Does y? So the only part of a monomial, okay, Eric just asked that question, this is a monomial. The only part of this term that I have to move is the part with the negative exponent. So I leave 16y in the numerator. And then the only part that I move is the x to the negative sixth so that it can be written with a positive exponent. All right? Now, I want you to do these last two. 12 to the negative third power, I want you to write this number, write this power using only a positive exponent, and same thing with x to the fourth, y to the fifth. All right, so what's the first one going to be? Just tell me. What is it going to be? 1 over 12 to the third. Very good. Okay, because I just move it into the denominator, so I can reverse the sign of my exponent. All right, now, what about your second one? What about the second one? Do you agree?
Yeah.
The only term I needed to move was the negative. I can leave y to the fifth in the numerator because it was already positive over x to the fourth. All right, very good. Okay, so that's it for example 1. Let's look at the checkpoint real quick. Turn in your books to, we do have time. And since we're missing so many, it would probably be helpful to do a few more problems. Go ahead and turn in your book to page 199. Page 199, numbers 1 through 4. Let's go ahead and do these real quick. It's exactly like what we just did. So you're just writing the expression using only positive exponents. Do numbers 1 through 4. Okay, so number 1, what's number 1 going to be? 1 over 5 to the second power. We move it to the opposite side of the fraction. All right, number 2, 1 million to the 0 power, 1. Number 3, 3y to the negative second.
3 over y is 6.
Did you get that, Aliana? 3. I leave 3 in the numerator because it doesn't have a negative exponent, so I leave it over y to the second. Did you get that, Eric? Did you get it? Okay, so on number 4, which term do I need to move to the denominator? A to the negative 7th. So I leave b because it doesn't have a negative exponent. B to the 3rd over a to the 7th. Okay, that's number 4. Anybody get all 4 right? Okay, good. Good job. Alrighty, moving on to example 2. Now in example 2, they don't care if we have a negative exponent in our answer. They just don't want us to have a fraction in our answer. Okay, so if we're looking at the first one, 1 over 16. Well, 16 has an understood exponent of what? There's an understood exponent of 1, right? So if I'm going to move it to the opposite side of the fraction, if I'm trying to move the number in my denominator into the numerator, I have to change the sign of my exponent. So instead of it being 1 over 16 to the first power, it's going to be 16 to the negative first power. Or is there a number that could be multiplied by itself to equal 16?
4.
4 times 4, right? So 16, so instead of it being 1 over 16, it could be 1 over 4 squared. Could it? Is that the same thing?
Yes.
And then if I write that not as a fraction without the fraction bar, it would be 4 to the negative second power, right? On your homework tonight, I don't care which way you do it. If you can find a number, like a square root, you could use that, or you can just use the number that's in the denominator. I don't care. But what do we do here? We wrote the number without the fraction bar. That's what we're trying to go for. So whatever term is down here in my denominator, I need to move it. So that means if my exponent is positive, when I move it to the numerator, what does it become? It becomes negative. Okay? So look at number 2. Now, if I want to move c to the third to the numerator, it becomes a squared c to the negative third power. Okay? Whatever is in my denominator. All right? Now, this is a bad example. There's actually a typo in there. Let me give you another example. Let's say we have, I'm looking at your homework right now. Let's say we have 6y over x to the negative fourth power. I want you to write this fraction or this term basically without the fraction bar. Get rid of your denominator. What's it going to be? All right, so 6y stays on top. Or wait, not the y, because I've got to move the x. X to the negative fourth. When I move it, here's my rule. When I move a term to the opposite side of the fraction, it changes the sign. Basically, it's going to be the opposite sign. So if it's negative 4 in the denominator, what does it become in my numerator? Positive 4. X to the fourth power. And then y. So that would be how we would write it without a fraction. All right, see guys, it works both ways. Basically, what we know is that if we have an exponent and we move it to the other side of the fraction, it becomes the opposite sign. If it's a negative in the denominator, if I move it to numerator, it becomes positive. All right, so now we're going to cover how these negative numbers apply to the number properties that we learned in 4.5, the product and quotient of powers properties. Okay, so this is all coming together, basically 4.5 and 4.6. This is on your quiz on Monday. This is a very important example. All right, so it says find the product or quotient and write your answer using only positive exponents. We know that the product of powers property says if it has the same base, if I'm multiplying numbers with the same base, what can I do to my exponents? If I'm multiplying, I can add them. Okay, so I want you, this is the original problem, I want you to rewrite it with the base and show how you're adding your exponents. This will help you visually understand how the signs are looking, okay? So what is 10 plus negative 6?
4.
Positive or negative? It is positive. 10 plus negative 6 is a positive 4, so 5 to the fourth power. Did I write it using only positive exponents? Is 4 positive? Yes, so this is my final answer. But now let's look at the second one. 8n to the negative third over n squared. Well, my quotient of powers property says I always subtract the numerator minus the denominator. So this is 8n to the negative third, and then I subtract my denominator. Do you see why this step is important? Because now you can visually see, okay, negative 3 minus 2. What's negative 3 minus 2?
Negative 5.
8n to the negative fifth power. But is my answer written in only positive exponents? No. So how could I write it?
8 over n.
Can the 8 stay in the numerator? Yes, because it does not have a negative exponent. 8 stays in the numerator, but I have to move n to the fifth to the denominator in order to make it positive. So 8 over n to the fifth. Well, now look at the third one. Now, this is like a combination. Okay? I can simplify what's in the numerator, right? You learned that in 4.5. So I want you to simplify the numerator. Go ahead and do that. Okay, so when you simplify the numerator, what do you get? 18. 6 times 3 is 18. What about a squared plus 3 is a to the fifth? Everybody agree? 2 plus 3 over 2a to the ninth. Well, 18 over 2 reduces to what? Reduces to what, guys? 9, right? So 9a to the 5th minus 9. Well, what's 5 minus 9? 9a to the what? Negative 4th power. But can that be my answer? No, because I have a negative exponent. Don't say it out loud. Write your final answer. Don't say it out loud. Samantha, what'd you get?
I got 9 over a to the 4th.
9 over a to the 4th. All right, good job. All right, so now let's do a little bit more practice on these. This is a really important concept. All right, so let's start with the multiplication. All right, so I've got some negative exponents in there, and I need to write my answer using positive exponents only, okay? So I want you to answer these 4 questions, and your answers have to be written using only positive exponents. Okay, so 3 to the negative 7th plus 11. What's negative 7 plus 11? 3 to the 4th power. And guys, I do want you to write this step, this middle step on your homework. It just really helps give you that visual, okay, especially with negative numbers. In 4.5, I wasn't too worried about it because it was only positive and it was pretty easy. On these, I think it's important that we see, okay, negative 7 plus 11, that does give me 4, so that's my final answer. But now look at the next one. 5 to the negative 8 plus negative 7. Well, what's negative 8 minus 7? Negative 15. Well, is that my final answer? 1 over 5 to the 15th power. I have to move it to the other side of the fraction so that it becomes a positive exponent. So same thing goes with the next one. It's going to be m to the negative 4th. So I have to write it how?
1 over m to the 4th.
Did you get that, Aliana? 1 over m to the positive 4th, right? That's how I write it as positive. I move it to the other side. Now, a to the negative 2nd plus 10 is just a to the 8th. Anybody get all 4? Did you get all 4 right? Awesome, guys. Good job. All right, one more slide. I want to just practice some more division problems. So on the checkpoint, these division problems, we've got, all right, I want you to simplify and write your answers using only positive exponents. All right, so in the first one, this is pretty much what we've been doing already. 2 to the negative 3rd minus 4. Well, that's 2 to the negative 7th, and how do I write my final answer? 1 over 2 to the 7th. Did you get that one right?
I just got 2. I got that one wrong.
No, you have to subtract 4, though.
I got all these wrong.
You have to subtract 4. Look at the second one. Look at the second one, and I'm going to let you do the last 2. 7 to the 2nd power minus negative 8. Because quotient of powers says that you subtract the exponents if they have the same base. Well, what if it's already negative? It makes it a double negative. 7 to the 2nd power minus negative 8 becomes 7 to the 2nd power plus 8, 7 to the 10th. Now that you've seen that, I want you to try to do the last 2. Okay, so we have 5. Okay, we can't do anything with 5. K to the 3rd minus negative 9. I subtract them, and it's already negative, so that becomes a double negative, 5k to the 12th. Okay, what about the 4th one? B to the negative 4th minus negative 6. Because you have to subtract them, and it's already negative, so it becomes a double negative, b to the negative 4th plus 6, b squared. All right, so that's it for your lesson. I do want to modify homework. As a reward for you watching all 19 and a half minutes, you now are hearing also that I will not be grading numbers 40 or 42, so you can leave those off of your homework. And if you understand that, that's everything you need to know for 4.6.